these are species that we know for a fact empirically through looking through their typical habitat, doing exhaustive searches, that we just simply can't find them anymore. Species that are extinct in the wild meet those same criteria as the first for the wild. However, we still have certain viable specimens held in captivity. This is Lonesome George. He is a Pinto Island tortoise, was unfortunately. He was the last remaining member of his species until 2012 when he died, hence Lonesome George. Again, these are species that are extinct in the wild, but we have captured a few specimens that, is that a question? Yeah, what's that?
Is Lonesome George a metaphor for somebody in this room?
Perhaps. Our last category is possibly extinct. Now, this is similar to our first category in that we've been looking for these species and we can't find them in the wild anymore. However, we haven't been able to perform the exhaustive surveys that are required for extinction, in part because these are more recent. So this is the Panamanian golden frog. There's a fungus called chytrid, which has been ravaging amphibians in Latin America, which has wiped out species such as this, but we haven't had enough time to go and make sure that they're actually gone. These are also held in captivity as well. So with that in mind, the next terminology is determining what taxonomic groups we're going to be looking at. A taxon being a unit of biological classification, looking at different structures of the hierarchies of animals. The one we're going to be talking about for the most part today is the one we're most familiar with, species. Species being the lowest of this hierarchical chart, which is anything that shares common characteristics and can breed with members of its species, but not with members of not its species. So that's its defining characteristic. Okay, with that in mind, how do species go extinct? There are lots of different ways this can happen, and this certainly won't be an all-encompassing discussion of how species can go extinct. But one major way in which this can happen is through selection. Selection being a process by which certain traits or characteristics are selected for in a given environment due to any number of circumstances. So this could be, the ones we all know about, giraffes with long necks, able to beat out competitors with shorter necks, which then pass on that trait to their offsprings thanks to their ability to survive and pass on that genetic information. Okay? That's basically the process of selection. And for the purposes of our examination of extinctions, we're going to see changes in the criteria that are selected for when something like this turns into a habitat that looks more like this. Whether we're using this as agricultural land, grazing land for our domesticated animals. And most particularly and most recently, thanks to the Industrial Revolution, like this. Again, the criteria that are selecting for certain traits are changing drastically, and in this case, faster than species can actually evolve to adapt to those. Evolution is a process that takes hundreds of thousands to millions of years. And as we're going to find out today, the process by which this is happening far more rapidly than they were able to adjust to. So with that in mind, we've got to try to figure out how many species we're losing. We'll come back to this in a sec, but our basic outline here is we're going to try to figure out the extinction rates before humans. Just like any experimental design, this will be our control. Then our experimental variable will be figuring out extinction rates with humans, see if they're statistically significant there, and then decide whether this difference might be correlated with human activity. So the first step is really hard, okay? We can try to establish a baseline. However, in order to determine how many species are actually being lost, we don't know how many there are out there, and we're finding 15,000 new species on average every single year. So cataloging and crossing off names that have gone extinct in order to determine the actual rate is prohibitively difficult. Because of that, previous iterations of this study have focused on modeling, specifically the species-area relationship. And all this is trying to take something we know and use it to find out something we don't know. In this case, we have information we know, in this case, habitat. We are aware of a relationship between habitat and the number of species that can exist in a given habitat. Based on that, if we can figure out how much habitat loss is going on, we can figure out how much species loss is going on. And habitat loss is much more easy to determine. Through satellite imagery, long walks in the wood, we can figure that out whereas figuring out the number of species lost is much more difficult. The problem with this is that it hasn't been very accurate, and it's resulted in a stigma. Typically, when you have information that ends up not being as accurate as you'd like it to be, particularly if it seems exaggerated in order to promote a political agenda, which this may have done, it creates a stigma with the public, and it kind of invalidates any future work that's done on a given topic, which is a really challenging obstacle to overcome. So what our paper has done, differently from the last one, is largely similar. Figure out the extinction rates before human, figure out extinction rates with humans, and finally figure out whether there's a difference and decide whether it's due to humans. But what this is doing that's different is we're not going to model anything out. We're going to miss out on some species because we have simply imperfect information. However, as a conservative baseline, we're going to try to figure out how many extinctions we know have occurred. Only information we know, no more speculation. Let's create a conservative baseline estimate. So, the first step, again, is figuring out the extinction rates before humans. This focused specifically on the fossil records of mammals. Why do you think we would have picked mammals? Anyone want to hazard a guess? No, go ahead.
Yeah, big fossilized bones.
Good, big fossilized bones. That's exactly right. Go middle school. There we go. The same exercise wouldn't be as fruitful with insects, for example. Anything that doesn't have as reliable of a fossil record is going to be more challenging to determine an actual accurate background. So,